Astroparticle physics is a relatively young discipline, the intersection of elementary particle physics, astrophysics and cosmology. We are getting very interesting results in this field during the recent years, improving our understanding of the universe.
My PhD project focuses on the detection and study of high-energy galactic cosmic rays with space detectors.
Here at GSSI, we focus studies on a lot of theoretical research, including into cosmic rays, neutrinos, gravitational waves, and cosmology. Me specifically, I'm involved in the research of high-energy neutrino astronomy. At the highest energies, neutrinos specifically represent an ideal multi-messenger candidate in that they are electrically neutral and travel cosmic distances without interaction or deflection. However, because they make ideal candidates, they are also extremely hard to detect. My research involves trying to find methods for improving their detection capabilities. Specifically, I'm involved with the POEMA and USO SPB collaborations, which seek to use the Earth and its atmosphere as large instrumental volumes to detect the high-energy astrophysical neutrinos.
GSSI is the perfect environment that you can find to work together with theorists, people that observe the sky and make that analysis, and people that develop instruments. And it's really a place where there is a strong synergy among different fields and different type of expertise.
The PhD program in astroparticle physics at GSSI lasts 4 years. During the first year, the students can choose either long or short courses, and the idea is that at the end of the first year they have a very solid background in the discipline. They can propose a research project that can be carried on during the following 3 years under the supervision of one of our faculty members or one of our visiting professors.
Kind of coming in, a lot of master students don't have all the experience necessary to be fully informed on making that decision, and I think it's quite helpful for choosing something that best aligns with your interests.
So during these 3 years they are fully embedded in our research groups, which cover many aspects of astroparticle physics, starting from dark matter searches or the study of neutrino properties. These are experiments which have been carried on underground because they need to be shielded from the background due to the huge cosmic radiation.
My PhD program here in GSSI is taking place at the Gran Sasso National Laboratories at the Cuore experiment, which is one of the experiments at these underground laboratories, which is one of the world's largest facilities in the search of rare event. The name Cuore stands for Cryogenic Underground Observatory for Rare Events, and it is an experiment searching for the neutrinoless double beta decay, which is one of the most important topics in the field of experimental neutrino physics, since its possible observation would shed light on several properties of neutrinos which are still unknown. It is important for us to work and to stay underground because we are searching for these rare events. For example, we also have important facilities for the search of dark matter direct interactions, like in the experiment of xenon and dark side, and also experiments for nuclear astrophysics.
A substantial amount of my current work is dedicated to spectral measurements of medium mass nuclei with a dark matter particle explorer. These medium mass nuclei are boron, carbon, nitrogen and oxygen up to the highest attainable energies. An equally significant amount of this PhD thesis will be dedicated to the development and the realization of the plastic scintillator detector for the HERD space mission. HERD stands for High Energy Cosmic Radiation Detector and will be an upcoming space mission that will provide substantial insight on cosmic ray physics up to the highest achievable energies in space.
A second branch of research activity in GSSI covers the study of these cosmic messengers coming from very distant sources in our galaxy or even outside our galaxy. These are high-energy particles, protons, electrons, photons, neutrinos, that bring us very important information.
The study of highly energetic astrophysical phenomena in the universe is one of the most intriguing scientific areas of research. Such phenomena can lead to the emission of cosmic radiation that consists mainly of protons, helium, heavier nuclei such as carbon, oxygen, all the way up to iron, with contributions from electrons, gamma rays, and neutrinos. Cosmic radiation is detected both directly from space detectors and also indirectly with ground-based detectors in a very wide energy range. By detecting cosmic rays, we are able to determine their acceleration and propagation mechanism in the universe.
Gravitational waves were also discovered and detected, so there is a third branch, GSSI, fully dedicated to the detection and study of this new messenger. So putting together all this information, we can really understand what is happening in these very far corners of the universe, far in space and time.
From here, we look at the universe through gravitational waves, through the electromagnetic emission, and also through particle. We have the opportunity to study the most energetic phenomena in the universe, like the merger of black hole, the merger of neutron star, the explosion of the stars. We are part of collaboration like LIGO and Virgo for the exploration of the universe through gravitational waves, but at the same time we access the fantastic data from ESO telescope, so for example VLT, or we explore the data from the high energy satellite, XMM, SWIFT. We are part also of the Pierre Observatory. So you can have really here all types of data and the possibility also to model all this data. We are looking also to the future, and so now we are exploring the science case of instruments like the Einstein telescope that will allow us to arrive to the early universe and to study the dark energy through gravitational waves. We have also dreamed, like for example, using the moon as a gravitational wave detector. Here you can find the present and the future of multi-messenger astronomy.
One thing I found really unique about the PhD at GSSI is that in the first year, you are required to take only courses, no research work, which to my knowledge is much different than other universities. And it allows you to develop sort of a broad experience over multiple topics before you actually pick a PhD supervisor and thesis topic.
The everyday life of a GSSI PhD student involves living and working in a vivid and friendly environment that is provided by the synergy of GSSI, of the Gran Sasso National Laboratories and the very welcoming city of L'Aquila. Students are able to deepen their knowledge, to share ideas and to grow scientifically with a series of well-organized lectures, discussions, weekly seminars and outreach events.
One of the things that I appreciated most to performing my PhD here was to know and grow scientifically, and also with my friends, with this multicultural environment, so that I could enlarge very much my knowledge of science and also of cultures.
Students are able to roam around the very beautiful region of Abruzzo and discover sceneries.
All this make GSSI one of the best places for a student to have his PhD in astroparticle physics.